I have the wrong word again. It shouldn't be how do you multiply exponents. It should be when do you multiply exponents. So in this video, I'm going to demonstrate when we multiply the exponents. In the previous video, you learned when to add them, and now we'll learn when to multiply them. This is just a reminder slide, and this is one that I showed you in the previous video of when you know an exponential expression is completely simplified. So this is just a little reminder, and if you want, you can rewrite these steps down to make sure when an expression is fully simplified. Let's go ahead and evaluate this expression. 6 to the 7th power, again to the 4th power. So this is a power raised to another power. Right, we got this kind of like external exponent that we need to deal with. So in order to evaluate, I'm going to write 6 to the 7th 4 times. Times 6 to the 7th times 6 to the 7th. And by the way, you can do this in your calculator and double check to make sure you get the correct answer. And as you notice, I wrote it 4 times, and we learned in the previous video that if I have 6 to the 7th, and I have 6 to the 7th multiplied by itself 4 times, that all I need to do is just add the exponents. So I'm going to add 7 plus 7 plus 7 plus 7. And when I do that, I end up getting 6 to the 28th power. So how do you think there's an easier way for me to do that instead of me having to write all these steps? Well, whenever you have a power raised to a power, you just multiply the exponents. And for me to remember when to multiply the exponents, it's when I can circle them. So here I get 6 to the 7th times 4 is the same thing as getting 6 to the 28th power. And this is my simplified expression. So when do you multiply exponents? Well, when you have a power raised to a power is when you multiply the exponents. So you have to remember, sometimes you multiply, sometimes you need to add. Depends on the expression. Okay, here are 4 examples to help us apply the property that we just learned of when to multiply the exponents. Remember the list of the bullet points of when an expression is not fully simplified, because you want to keep that in mind right now as we go through these examples. So let's look at example A. Here on example A, we have 5 squared to the 4th power. So this is a power raised to another power. And notice how I can circle the exponents, which means I should multiply them. So this becomes 5 to the 2 times 4 power, which equals 5 to the 8th power. And because the exponent is greater than 4, we don't need to evaluate it further. Okay, here we have, let's look, at example B. You have 4 to the 3rd power to the 0 power. So here we're going to multiply the exponents. So I get 4. 3 times 0 is 0. And any number raised to the 0 power is 1. That's our final answer. Now let's look at C. And just to note, you must have the same base to combine any exponents. So here I have the bases of x, so we're good. I'm going to multiply the exponent here, and I get x to the negative 15 power multiplied by x to the 4th power. And now I'll have to use the property I learned last video, and I need to add these two exponents. So this becomes x to the negative 11th power. And remember, this is not fully simplified because it has a negative exponent. So to make it positive, I'll put it in the denominator and make it happy. So it becomes 1 over x to the 11th power. And that's my final answer. Look how simplified we made it. Now let's do part D. Once again, I need to multiply here. So I get a to the 12th power multiplied by a. Negative 2 times negative 3 is going to give us positive 6. And now I'm multiplying the bases, so I need to add the exponents. So this becomes a to the 18th power. And I have no negatives. I have no powers raised to other powers. I have no other bases except for the a. So this is the final simplified form of our expression.